All right, now we're doing more trig. We are on 9.5 now. 9.5 is on sine and cosine. So please remember, sine is, black, why are we not writing? Sine is the ratio of opposite over hypotenuse, and cosine is the ratio of adjacent over hypotenuse, okay? So here we go. In number 5, find sine of D, sine of E, cosine of D, cosine of E. Write each one as a decimal and a fraction. So let's go. Let's start with sine of D. So over here on number 5, I'm going to identify hypotenuse. If I'm at D, if I'm right here at D, for sine, I need opposite over hypotenuse. So from D, opposite is 28. Over, hypotenuse is always hypotenuse no matter what. So over 53. So 28 over 53 is 0.5283. Okay, so that's sine of D. Let's see what, Let's see what sine of E equals. So now if I'm standing at E, opposite is 45, and hypotenuse is still 53, always 53. So 45 over 53, and then 45 divided by 53 is 0.849. Because it was a 0.5, so the 5 makes me round that 0 to a 1. Okay, now let's see what happens when we do cosine of these guys. So I'll do cosine of D and E, but I'll start with cosine of E. So at E, for cosine, I need adjacent over hypotenuse. So here I am at E. Adjacent is that 28 over hypotenuse is 53. It's always 53 in the triangle. It's not going to change in this triangle. And I notice, wow, look at that. Cosine of E is the same as sine of D, right? In the same triangle, for sine, the opposite to D is the same as the adjacent to E, which is why within this triangle, within every right triangle, that's what happens. So this is the same problem I already did, 0.5283. And what do we think will happen with cosine of D? So for D, if I'm standing at D, adjacent to D is that 45, which is the same as opposite of E when we did sine. But for D, adjacent is 45, hypotenuse is 53, so I get the same ratio as this, all right? So these two angles are complementary because they add up to 90. They add up to 90 because then 90 plus that 90 is 180. So you can see that the relationship between sine and cosine of complementary angles, 0.8491. Very, very interesting. Number 7. I want, for number 7, sine of D. So from D, here is the hypotenuse. Across the right angle is the hypotenuse. Come on, why aren't you writing suddenly? Okay. So from D, opposite is 13 rad 3 over adjacent. No. Sine is opposite over hypotenuse. I'm sorry. Opposite, 13 rad 3 over hypotenuse, which is 26. 13 over 26 reduces. So this becomes root 3 over 2. And then a decimal for square root of 3 divided by 2 is 0.8660. And then following this pattern, I expect cosine of E to be the same thing. So for E, cosine would be adjacent, which is this guy, over hypotenuse. So it is exactly the same thing. So that's going to be the same, root 3 over 2, which is 0.8660. If you're thinking I'm going too fast, what happened? Did you look at number 5 or did you fast forward to 7? If you did just fast forward to 7, go back to number 5 because that's where I explain in more detail why these two are the same. All right, let's keep going. We'll also do sine of E, which we expect will be the same as cosine of D. So if I'm looking at sine of E, I want the opposite, which is the 13, over the hypotenuse, which is 26, so 13 over 26, which reduces to 1/2. And that is the same as cosine of D, because for cosine, we go adjacent. So adjacent to D is the same 13, and the hypotenuse is 26, exactly the same thing. 1/2, or a decimal would be 0.5. Okay, number 9. Well, let's take what we learned here. So we said the two acute angles in a triangle are complementary. Which means they add up to 90. So what happens here? Sine of 37 will be the same as cosine of the complementary angle. So to get the complementary angle to 37, I have to go 90 minus 37. That's equal to 53. So sine of 37 is the same as cosine of 53. It'd be the same as if there was a 37-degree angle here and a 53-degree angle there. The sine of this guy would be the same as the cosine of that guy. So in number 11, again, I want to know the complementary angle to 29, so I'll subtract it from 90. I'll get 61. So that means that sine of 29 degrees is the same as cosine of 61 degrees. Write an expression in terms of sine. Well, the same works in reverse. Cosine of 59 is the same as sine of 90 minus 59, which is the sine of 31, right? Boop, 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 boop. Okay, 31. I'm sticking with it. Cosine of 73 is going to be the same as sine of 90 minus 73, which is sine of 17. Okay. Yeah. Here we are now finding the value of each variable. Ooh, we are solving for x and for y. Okay, they give me this 32-degree angle. So let's go see what we have in relationship to the 32-degree angle. 18 is the hypotenuse. I always like to label the hypotenuse. From 32, the opposite side is that x, and the adjacent side is that y. So if I wanted to solve for x, I would be looking at opposite and hypotenuse. Opposite and hypotenuse is so sine. So I'm going to set up sine of 32 degrees, and that equals the opposite, which is x, over the hypotenuse, which is 18. And now to solve this, I just multiply both sides by that 18. And I get that x equals 18 sine of 32 degrees. And now if I wanted an exact answer, that would be it. Okay, as weird as it looks, that is a great exact answer. But if we wanted to round to the nearest tenth, we would go to our calculator and we would type in, learn what it takes to do this on your calculator, 18 sine of 32, and ask me in class for help if you don't know how to use your calculator. 9.5. All right, let's keep going now. We want to also find y. Y is the adjacent, and then we also have hypotenuse. So that's going to be ca. Adjacent and hypotenuse is cosine. So ca, and then the last one, just so you guys don't forget, is toa. SOHCAHTOA. Okay. So here we are. At this angle, we're going to go with cosine. So cosine of 32, guys, sine, cosine, tangent, we always put an angle measure inside them. So cosine of 32 degrees, and it's cosine of 32 degrees. It's not cosine times 32 degrees. Cosine of 32 degrees is adjacent, which is y, over hypotenuse, which is 18. And then again, we multiply both sides by that 18. And we get that y equals 18 cosine 32. Now again, that's a perfect answer. If I said don't round, that's what you would give me. And then if I said to round, you just learn how to put that in your calculator. And in this case, it's 15.3. Okay. Number 19. Numero 19. Okay. Here we are at 71. We look at what we've got. So here we have hypotenuse. From 71, V is the opposite. And from 71, W is adjacent. And so here I go. To find V, I'm looking at opposite and hypotenuse, and that is so, sine. So I go sine. Sine of what? Always an angle, 71 degrees, equals opposite, which is V, over hypotenuse, which is 5. Then all I gotta do is multiply both sides by 5 to get that V equals 5 sine of 71. Which is 4.7. And if you're wondering, does this answer make sense? You could look back at the triangle. In this triangle, that side with that angle and being less than the hypotenuse, 4.7 makes sense. Okay, in our previous problem, 15.3 for y, that makes sense. 9.5 for x, that makes sense. You can look at the context and see if it makes sense. All right, off we go. We want to find w as well. Now w is adjacent and hypotenuse, so that's adjacent. Hypotenuse is ca. So we do cosine. Cosine of what? Always an angle. Equals opposite. No, cosine is adjacent, which is w over 5. Multiply both sides by 5. I'ma get w equals 5 cosine 71 degrees. 5 cosine 71. We have 1.6. Approximately 1.6. Which again also makes sense. If this angle is 71, this angle is 19. Okay, this angle is far smaller than that 71. So the side across from it should be far smaller than the side across the 71. Check to see if it makes sense. Number 21. I have this 48-degree angle right here. Here's the hypotenuse. Here is opposite. And here is adjacent. So looking at this, with the angle, I've got opposite, adjacent, hypotenuse. All right? Now, I don't know opposite and hypotenuse. So I can't use both of them. I can only use one of them. I must use adjacent to begin. All right? Now, if I have to use adjacent, my options are either cosine or tangent, because they both have adjacent. I just can't start with sine, because then I'd be looking at opposite over hypotenuse, b over a, and I have too many variables and I cannot solve. Being that this is a sine, cosine, whatever chapter, section, sine and cosine section, let's do cosine. So we're going to go cosine of always an angle equals, and then we go adjacent, which is next to, which is 10, over hypotenuse, which is a. Okay, but you could have, if you wanted to, you could have done tangent of always an angle. And you could have done, in that case, for tangent, it'd be opposite over adjacent. So you'd be looking at b over 10. All right? Okay, guys, I have gotten myself invested in doing this both ways. All right? So follow along with me. You only need to do this side, okay? But just to prove to you that it works, I'll also do the other side. You're going, I didn't ask for proof. That's okay. You're going to get it. Alrighty, so now we can cross multiply and we get a cosine of 48 equals 10. Now again, if you remember the shortcut I told you in the other video, you could switch cosine 48 and a. That's a shortcut. But the correct process is this. We divide both sides by that, and we get that a equals 10 divided by cosine of 48. So 10 divided by cosine of 48 is 14.9. So we got approximately 14.9 for a using cosine. Let's see what tangent would have done. For tangent, ooh, it comes out nicer. Look at that. The denominator is 10, so all I got to do is multiply both sides by 10. And then this cancels, and I get that b equals 10 tangent of 48, which is approximately, let's see, 10 tangent of 48 is approximately 11.1. Okay, I guess doing it like this, we're done. Okay, we found A and we found B. But I think what this problem wanted you to do is that after you found A to be 14.9, you could now do sine, opposite, and hypotenuse to get B this way. So we could do sine of 48, always an angle. Sine of 48 equals opposite, which I don't know, so b, over hypotenuse, which is 14.9. Now that's a rounded answer, so it is going to affect the accuracy of this. But I multiply both sides by 14.9, and I get that b equals 14.9 sine of 48. And that comes out to 11.1. Same thing. All right. I don't know. I guess I would argue that I would do the whole problem this way, because why use a rounded answer here, or an answer that you may have potentially made a mistake finding, and now you're going to get this part wrong also because you used that wrong answer. But if you do it this way, you're only using the values the problem gave you to find each of these. All right. That was 21. Ooh, we are trucking along. After 21, I asked you guys to do 25. So let's look at the error here. They said, okay, let's go mark this up. So this is hypotenuse. Always mark the hypotenuse. They said sine of A. So they're looking over here where A is. And then they said that it's 5 over 13. Well, 5 from A is the adjacent. And from A, this is opposite. So instead of doing opposite over adjacent, sine of A, they should have done 12 over 13. Okay, that's the problem. Or maybe they found cosine of B instead. I'm sorry. Maybe they meant to find sine of B instead of sine of A. Whatever, it doesn't matter. You can also say that sine of B equals 5 over 13. Because now if we're looking at B, then this guy is opposite. And this guy is adjacent. All right? So then it would be 5 over hypotenuse 13. So one of those, either way. Okay, the top of a slide is 12 feet from the ground, has an angle of depression of 53 degrees. Angle of depression means the angle going down with a horizontal line. Okay, what is the length of the slide? This is the length of the slide. This is what we are trying to find, x. So let's see what we're looking at, all right? We are looking at this angle. X is the hypotenuse. And then we also have involved in this problem the opposite side. So if I have opposite and I have hypotenuse, that's O. So sine. Sine. Sine of what? Always an angle. Sine of 53 degrees equals opposite, which is 12, over hypotenuse, which is x. Guys, I really hurt my hand banging on the table just now, so please don't forget, always an angle goes inside a trig function, all right? Okay, now, if you want to do the shortcut, you just swap these two, but I will not do shortcuts. So, I'll put this over 1, I'll cross multiply, and I'll get x sine of 53 equals 12. Divide sine 53. And we get x equals 12 over sine 53. Calculator, what is that? Calculator says 15.0. What is my units here? Feet. The slide is 15 feet long. Does that make sense? Yeah, it makes sense. It's the hypotenuse. It's got to be longer than that 12, and it is. We good. Okay, 29. Let's see what this is talking about. Problem solving. You are flying a kite with 20 feet of string extended. The angle of elevation from the spool of string, that's a word I didn't know, to the kite is 67. All right, here we go. So we've got the spool here. All my pictures are dots and lines, you guys. So this is the spool. This is the string. Up here is the kite. All right, I just contradicted myself. There's the kite. Oh, it's so pretty. Okay. I have 20 feet of string extended here. All right. So that's that 20 feet. The angle of elevation. So that's our angle going up from the horizontal. Angle of elevation and angle of depression always go from a horizontal. So you never put a vertical line and look at the angle. Never. Okay? It's always a horizontal line. If they gave me angle of depression, I'd make a horizontal line up here and look at that angle. Either way, they're the same because these are alternate interior angles and these are parallel lines. Anywho, okay. This is 67. And then draw and label the diagram. Check. Okay. How far off the ground is the kite if you hold the spool 5 feet off the ground. Okay, here we go. Here's what they're saying. They're saying that you're standing here holding this guy. So like you're like this. Okay? And this distance right here is 5. So you're 5 feet off the ground, and then they want to know how far off of the ground. That was awful. Okay, can you go over here without getting minimized? Thank you. Okay. Boop, 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 boop. We go to here, and then we go to here. All right. So you guys, we've got to be a little careful. This is 5 feet, so this is 5 feet. This 67-degree angle is only going to be able to tell me this distance, all right? This is the opposite distance to that 67. We'll call this x, all right? But at the end, our answer is going to have to be whatever we find plus 5. So remember that, jot that down so you don't forget. And let's go. This is 67. This 20 is the hypotenuse. So I say sine of 67, sine of an angle always is opposite, which is x, over hypotenuse, which is 20. And then all I got to do is multiply both sides by 20. So x equals 20 sine 67. 20 sine 67 is 18.4. So this distance is 18.4 feet, but I'm holding the spool 5 feet off the ground, so really it's 23.4 feet. How far off the ground, blah, 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 blah. Describe how the height where you hold the spool affects the height of the kite. Well, the higher I hold it, that's just higher that I've got to add to this triangle, okay? Alrighty. That's it.